The digital revolution has ushered in a new era of technological innovation, and at its forefront is blockchain technology. This presentation explores the core concepts of this groundbreaking technology: security, decentralization, and scalability. These three pillars form the foundation of blockchain's potential, yet they also present a significant challenge known as the blockchain trilemma. This trilemma highlights the difficulty of simultaneously optimizing all three properties, forcing trade-offs that require careful consideration. We will explore why enhancing one property often comes at the expense of others and examine the ongoing efforts to overcome these limitations. From the intricate workings of cryptocurrencies to the secure management of digital identities, blockchain technology holds immense promise. However, its widespread adoption hinges on addressing a fundamental challenge: the blockchain trilemma. This concept underscores the inherent difficulty in optimizing security, decentralization, and scalability simultaneously. For instance, enhancing decentralization by increasing validating nodes can decrease scalability by slowing down transaction processing. Conversely, while simpler consensus mechanisms might boost scalability, they could introduce security vulnerabilities. The pursuit of a perfect balance within the blockchain trilemma is an ongoing journey, driving continuous innovation and the exploration of novel technical solutions. Navigating the complexities of blockchain development requires a deep understanding of its core components, and at the heart of this lies the blockchain trilemma. Popularized by Vitalik Buterin, a key figure in the blockchain space, this concept emphasizes the challenge of maximizing security, decentralization, and scalability concurrently. This can be visualized as a three-way balancing act where improvements in one area often lead to trade-offs in others. Security ensures the network's resilience against attacks and protects data integrity, much like a digital fortress. Decentralization distributes control, preventing single points of failure and promoting democratic governance. Finally, scalability enables efficient handling of high transaction volumes, similar to a well-designed transportation system. Achieving a balance among these three pillars is paramount for the widespread adoption of blockchain technology. In today's digital age, control over information is a growing concern. Decentralization, the foundation of blockchain technology, addresses this by distributing control among all participants, preventing any single entity from holding absolute power. Unlike traditional centralized systems like banking, where a central authority manages all records, Bitcoin exemplifies this decentralized approach by sharing data across its entire network. This eliminates the need for intermediaries and fosters a trustless environment, paving the way for Web3, where users regain control over their data and online identity. Building upon the decentralized nature of blockchain, ensuring its security is paramount. This involves safeguarding the integrity and immutability of the blockchain through cryptographic protection, consensus mechanisms, and network size. Each block in the chain is linked cryptographically to the one before it, creating a tamper-proof chain of records. This ensures that any alteration to a block is immediately detectable. Furthermore, consensus mechanisms like Bitcoin's proof of work require substantial computational effort to add new blocks, making it difficult for malicious actors to tamper with the blockchain's history. The size of the network also contributes to its security. A larger network with more participants makes it harder for any single entity to gain control and compromise the system. These measures work together to guarantee the blockchain's integrity and reliability. While security and decentralization are crucial, blockchain technology faces scalability challenges. Scalability refers to a blockchain's ability to handle a growing number of transactions per second, TPS. For widespread adoption, blockchains must process transactions quickly, affordably, and efficiently. However, balancing scalability with security and decentralization presents a significant hurdle. Traditional centralized payment systems like Visa process thousands of TPS, while Bitcoin and Ethereum currently handle significantly fewer. This disparity highlights the ongoing development needed to overcome these scalability limitations for broader blockchain adoption. Sharding presents a compelling solution to the blockchain trilemma. This technique addresses the challenge of scalability by dividing the blockchain into smaller, manageable units called shards. Each shard operates as an independent ledger, processing transactions in parallel, much like dividing a database for improved performance. This parallel processing significantly increases the network's transaction throughput. For example, with 4 shards, the blockchain could theoretically quadruple its transactions per second compared to a single chain. These shards communicate and transfer value through cross-shard messaging protocols. This ensures secure and accurate movement of assets between shards, similar to sending tokens between different bank accounts. Maintaining data integrity across shards involves the use of state roots and proofs. These cryptographic proofs, based on Merkle trees, efficiently verify the state of each shard, ensuring consistency and validity across the network. Finally, the main chain acts as the central coordinator, ensuring consensus and finality across all shards. The main chain upholds the security and integrity of the entire sharded network. Beyond proof of work lie alternative consensus mechanisms that offer different approaches to securing the blockchain. This exploration considers proof of stake, POS, and proof of authority, POA, as alternatives to the energy-intensive proof of work, POW. POW, as used by Bitcoin, requires solving complex cryptographic puzzles, leading to high energy consumption and potentially slower transaction processing. POS, conversely, allows participants to stake their tokens to validate transactions, making it more energy efficient and potentially more scalable. POA relies on validator identities for consensus, offering higher scalability but potentially compromising decentralization due to its reliance on a smaller, trusted group. Finally, hybrid models combine aspects of various mechanisms to optimize the trade-offs inherent in the blockchain trilemma. For instance, Binance Smart Chain uses proof-of-stake authority, POSA, while Conflux integrates POW with a directed acyclic graph structure for efficient block processing. Layer 2 solutions offer innovative ways to enhance blockchain scalability without compromising security or decentralization. These solutions process transactions off-chain, outside the main blockchain, while preserving the security guarantees of the underlying blockchain. 2 main categories of Layer 2 solutions are rollups and state channels. Rollups bundle or roll up multiple off-chain transactions into a single compressed proof submitted to the main chain. This greatly reduces the load on the main chain, boosting transaction throughput. 2 primary rollup types exist: optimistic rollups and zero-knowledge rollups. Optimistic rollups, like Arbitrum, assume transactions are valid unless challenged, prioritizing speed. Zero-knowledge rollups, like Scroll, provide cryptographic proof of validity for every transaction, enhancing security but requiring more complex calculations. State channels enable participants to transact off-chain, recording only the opening and closing states on the main blockchain. The Bitcoin Lightning Network exemplifies this approach, facilitating fast, low-cost Bitcoin transactions by moving most activity off-chain. As blockchain technology evolves, the question of its scalability becomes increasingly critical. This leads us to the blockchain trilemma, a fundamental challenge in the field. Currently, blockchain networks often struggle to achieve all 3 core properties: security, decentralization, and scalability. Most networks prioritize only 2, leading to trade-offs. For example, a network may be secure and decentralized, but struggle to handle a high volume of transactions. However, emerging solutions offer hope. Ethereum's roll-up-centric roadmap, for instance, aims to bundle transactions off-chain, increasing efficiency without compromising security. Similarly, high-performance modular blockchains are designed to compartmentalize functions, allowing for specialized scaling. These innovations are paving the way for global-scale applications by boosting scalability while preserving both security and decentralization. While achieving all 3 aspects of the trilemma simultaneously remains a challenge, ongoing research and development continually push the boundaries of what's possible. Ultimately, these efforts strive to create blockchain networks capable of supporting widespread adoption.